right, 13 and 14, we can do the same thing and find all the z-scores for all of our x's. And I'm gonna do that at the end so you can see all of them, but I'm not gonna waste that time in the video. I'll just pause it. I'll do one and then, so these are all your x values, and so your z-scores that correspond to it. Cheat, do it this way. Oh, no way I can fit in that box. I tried. Okay, the mean is 70, so to find a z-score, x, these are your x's, minus your mean of 70, divided by your standard deviation. So those are your x's. You're going to do this equation. If you're doing it this way, you're going to do this equation 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. Well, that's the same number. But x minus your 70 divided by 4.9. So alpha y equals, enter. The first number is 63 minus 70 divided by 4.9. Negative 1.4. We're looking for values, circle all the values of a z-score greater than 0.5. Why am I at a negative number? Negative 1.4. To get to a positive, I have to be above the mean. At the mean, it's 0. So you know all of these are below. These are all negatives. If you do 70 though, 70 minus 70 is 0. Doesn't matter to what we divide by 0. It's still 0. So we know it's at least over here. So I can skip all of these. So then I'm going to do 71. $73. $76. Okay, so 71 was 0.2. 73 was 0.6. There's two 73s. 76 was 1.22. Well, we're already greater than 0.5. This is 1.6. And just to fill it in, just so you have it, 1.2, negative 1, negative 0.6. So we're looking for z-scores. Circle all the values of z-scores greater than 0.5, bigger than 0.5. That's these, 1, 2, 3, 4, those 4. That's one way to do it. Another way to do it is to find the x value that goes with 0.5 as a z-score. So x equals, and go to your equation, z standard deviation times your z-score plus your mean. Z plus standard deviation plus my mean. So at 0.5, 0.5, my standard deviation is 4.9, and my mean is 70. 0.5 times 49.9 plus 70. 72.45. So any number greater than 72 would work, which we already did. I don't care which way you do it, they both work. Oh my goodness. Technical difficulties, hold on. I'm not skipping. Okay, here again, circle all the values that fall within one standard deviation of the mean. That's one standard deviation below and one standard deviation above. So the easiest way to do this is to go one standard deviation below and one standard deviation below. Or calculate all your z-scores. This takes a while, but it'll work every time. You'll get the answer right away, every time. This is a long way to do it. I would not suggest doing it this way, but x minus your mean divided by 7.9. And I'm not going to bore us to do that because if you're looking at the normal curve, great normal curve. Your mean goes in the middle, 20.5. That's a 4. 1 standard deviation to the right, 1 standard deviation to the left. So add 7.9, I'd get 28.3. Subtract 7.9, I get 12.4. So as long as it's in between these two values, we're looking for answers in between here, within 1 standard deviation away. So between 12.4, so 11's outside of that, and 28.3. 33 would be out of that. So that's all of these answers. So everything but 6, 11, and 33. Or if you did your equation, here are your answers. Negative 1.8, negative 1.2, negative 0.7, negative 0.4, negative 0.2, 0.5. I'm above the mean now. 0.6, 0.7, 0.96, 1.59. Falls within 1 standard deviation. So this is lower than 1 standard deviation. This is lower than 1 standard deviation. This is between 1 standard deviation and the mean, all the way to this. It's right before 1 standard deviation. So 2 ways to do it, but you have 1, 2, 3, 4, 5, 6, 7 answers. Okay. Normal CDF. So when you fill in the normal CDF, you go norm, and then you can look at your calculator. Second vars, 2. So you have the lower, the upper, the mean, and the standard deviation. You have the lower, the upper, the mean, and the standard deviation. So what percent of students have a shoe size between 7 and 11? So here's my lower, here's my upper, here's my mean, here's my standard deviation. So percent, we're looking for the area under the curve between a 7 and an 11, with a mean in the middle of 8.5. I did not space those accordingly, I just said it's in here. So normal CDF, my lower is 7, my upper is 11, my mean is 8.5, and my standard deviation is 1.5. Lower first, 7, upper, 11, my mean is 8.5, and my standard deviation is 1.5. So 0.7935 is the area, 0.7935, which will round to 6. And then to get a percent, you times that by 100. So 79.36%. So this answer was 0.793, and we rounded it to 6 to get that's the area or the probability. And then we times that by 100 to get the percent. So 79.36%. What percent of students will have a maximum shoe size of 9.5? Okay, the mean is in the middle, 8.5 is in the middle. If our maximum shoe size is 9.5, that's on this side, and we're going lower than that. So this maximum shoe size means we're going to the left. So we would love to put negative infinity in the calculator for our lower bound, the smallest number to the left, but we can't. So that's why I use negative 1, 2, 3, 4, 5, 6 zeros, just a very, very small number. To our upper, where we're stopping, 9.5, with our mean of 8.5 and our standard deviation of 1.5. Second, bars, number 2, normal CDF, negative 1, 2, 3, 1, 2, 3, 9.5, 8.5. Oh, those are already there. Not waste our time. And times that by 100. Makes sense, it's over 50, it's over half of my chart. of my normal curve, 0.7475. So that's 74.75%. What percent of students wear at least a size 6? At least is to the right. That's 6 or higher. The middle is 8.5, 6. The middle is the mean, that's how I know. 6 is on the left, at least, so a 6 or bigger. So we're trying to go to positive infinity this time. So normal, CDF, my lower bound, we're starting at 6. I wish I could go to infinity, but I can't, so I'm just going to use a big, big number. And then the mean and the standard deviation. This gives me my area under the curve, and I times it by 100. One, two, three, 1, 2, 3. 0.9522. 0.9522 times it by 100. 95.22%. What percent of the students wear shoe size between 8 and 10? 8's on this side, 10 is on this side, shade in the middle, between. So our low is 8, our upper is 10, our mean is 8.5, and our standard deviation is 1.5. Eight, 5. Oh, I flipped it. Lower first. You can't have a negative area. That doesn't even make sense. That does not even make sense. Second verse. 5, lower first, then upper. 8. Where am I getting 5 from? 8, then 10. I'll get there. 0.4719. That's the area or the probability. We times it by 100 to get to our percent. 47.19%. Okay, now we have z-scores. So that means this isn't x values, they have been standardized. Find the mean migration distance for a great blue whale. Was the mean of the great blue whale was that with a standard deviation of 327. What percent? So that's normal. Anytime we're looking for a percent, we start with our normal CDF. Since we're at negative, we're on this side, negative 0.76, because this is standardized now, because these are z-scores. So our mean is 0 and our standard deviation is 1. Anytime you're using a z-score, you have to use a mean of 0 and a standard deviation of 1, because they have been standardized. So less than's to the left. So again, negative infinity would be amazing, but we can't do that. So a very, very small number. I always do 6, negative 6/9 to negative 0.76. We have a z-score, so we're using 0 and 1. Negative 1, 2, 3, 1, 2, 3 to negative 0.76. We're using a z-score, so our mean is 0 and our standard deviation is always 1. So 22%, 22.36. So 0.2236, make sure I round it right. Yes. So 22.36%, because I times that by 100. All right, what percent of whales migrated less than 1,500? That's an X value, that's not a Z-score. So less than, so we're back to these numbers. I have a mean of 1750, that's in the middle. So 15 is on the left, so you know it's less than 50%. So we're trying to use negative infinity, but we can't. So we're going to use a very small number to 1,500. And we are now using the mean of 1750 and the standard deviation of 327. I ran over. Because we're using X values, not Z-scores. So that's already there, nice. 1,500. We're using a mean of 1,750 because it says it up here. And a standard deviation of 327. Less than 50%, 22.23%. 2, that's 7, bump that 2 up to a 3. 100, 22.23%. What percent of whales migrated between 16 and 2000? So in between normal CDF. 16,000 is our lowest number. 2,000 is our upper. These are X values. So we're using the mean of 1,750 and the standard deviation of 327. Whoops, not inverse. Normal. 1,600, whoops. 1,500, come on. 2,000. I'm still in inverse. Come on, I didn't want that. Second, bars, 2. There you go. 1,600, I'll get there. 2,000. Make sure you have enough zeros. People messes up because they don't have enough zeros. About 50% if you were estimating 0.4545. 0.4545 times 100 is 45.45%. So normal CDF, I meant to write this out way up here, gives you the area or the probability. And if you times that by 100, you get the percent. All right, what percent of data has a z-score greater than 0.09? We don't care about this problem at all. We could be talking about anything, but since we have a z-score, we're using a mean of 0 and a standard deviation of 1. So normal CDF greater than is to the right, a little past 0. This should be close to 50 because that's almost at 0. So 0.09 to infinity, or a very big number. .09, 1, 2, 3, 1, 2, 3, 0, and 1. Should be close to 50. 46%. 0.4641 times 100, 46.41%. Okay, that's that page. One last page to go.